Atrium is a desirable architecture feature to developers and architecture designer, not only by bringing nature light into the buildings, but also bringing the outdoor environment into the interior. So atrium is often referred as a indoor courtyard in many cases. Many impressive atrium can be found all over the world. But today we're going to talk about some special atrium, which is extend many levels, but the footprint is relatively small. So we call this tall and narrow atrium. So atrium in super tall building usually cannot have a luxury to occupy a big footprint because the construction is quite expensive. So today I'm going to talk about some unique atrium like this and the fire protection strategy in this kind of atrium. So example for this kind of atrium, tall and narrow atriums, are the first one, 42-story atrium in the Grand DoubleTree Hotel in Miami. The second one is the atrium in this building, which is the 32-story high atrium and in the hotel portion of this building. And the third one is the tallest atrium in the world right now. It's the 180 meters high atrium in Burj Dubai. So the fire protection and life safety concerns of atrium, is the first try to preventing the focus on preventing spread of fire, and of course also controlling the spread of smoke. In the tall atrium, since the atrium open to many levels, so if a fire happens in a tall atrium, potentially many occupants may have to evacuate simultaneously. So that's some three big concerns in the tall atrium. Because of the top of the atrium is closed, so the heat and the smoke may be accumulate at the top of the atrium. So if a fire happens at the lower level of the atrium, possibly there's a chance smoke can impact the top levels, which is far away from the fire, where the level where the fire occurs. So traditionally, one of the traditional solutions is to enclose the atrium with either with some kind of smoke barriers, either the glass windows with sprinklers or with fire shutters. In China building code, when atrium size over certain limitation, like 2,000 square meters, then the China building code requires the atrium to be enclosed by fire shutters. So the smoke barrier and the fire shutters are not always so favorable to the developers and the architects, especially the fire shutters in the tall and narrow atrium. Think about this. If you have a lot of levels, floor levels open to the atrium, you have to use a lot of fire shutters to close the atrium. One or two shutters failed, you may fail the entire atrium. So the protection with the fire shutters we think is vulnerable and unreliable. We try to compare with the so-called courtyard as with the same kind of a geometry as the atrium. So the courtyard, because you don't have the top enclosure, so the smoke can be released at the top of a courtyard. So in a courtyard, if the courtyard has a certain distance, for example, IBC requires if the courtyard distance is like 30 feet apart, then you don't need to provide any separations to close off the courtyard. In other words, you don't need the fire shutters, you don't need the smoke barrier. So we use the courtyard kind of compare with as a reference for the atrium geometry. So the atrium smoke control is not a new topic. So there are some empirical engineering calculations which is based on keep the smoke layer 6 feet above the top of floor. But that's a kind of an ideal solution, only applicable for the kind of a short and wide atrium. But in the tall and the narrow atrium, this strategy may not be applicable, because in the tall and the narrow atrium, the smoke layer cannot be always. It's really hard to create a clear smoke layer inside the tall and narrow atrium. So here's the following is the case study. We're going to talk about the how we develop the fire protection and life safety strategy in this 18-story atrium. This atrium is like this distance is only like 10 meters wide. It's really kind of a narrow, but it extends like 18 stories. So it's exactly the tall and the narrow atrium. So we just discussed the fire protection strategy. First of all, of course, how to protect prevent fire spreading from floor to floor. Okay, we rely on the sprinklers. We propose to have a limited fuel load combustible materials along the corridor. So the next issue is to prevent smoke spreading inside the atrium. So smoke barrier, we just talked about, is not so favorable for the architect. And the fire shutters, because the height of this atrium is not so reliable. It's a vulnerable solution. So so we think the smoke control is the most reliable solution for the smoke control, to keep a smoke. Okay, based on the 92B equations, the empirical equations, in this kind of a tall atrium, we may come up with a huge exhaust capacity, which is like 1,000 cubic meter per second. That's a huge number. If we provide such kind of exhaust, the exhaust system may bring a lot of negative impact to the atrium. Not only the big airflows, but also brings a lot of oxygen in case of a fire, may increase the fire. So we use the fire modeling analysis to evaluate the performance of the smoke control system. So there are several scenarios we took in this analysis. Actually, we have 5 scenarios. Actually, we start from the first one, the courtyard, which is we open the top of the atrium with the just rely on the natural ventilation to see how the performance of the natural ventilation going to be. And then we, in the natural ventilation case, we measured the airflow rate at the top of the opening, which gave us the 40 cubic meter per second compared with 1,000 cubic meter per second. That's a huge reduce. So we used the mechanical system, which is the scenario 1, to compare the performance, and then 100 cubic meters, 160 cubic meters. The fifth one is we increase the mechanical supply at the bottom of the atrium, but still we rely on the natural ventilation. We want to see if the mechanical supply whether the mechanical supply can help improve the smoke control system. Here's the modeling or some modeling results of the first scenarios. You can see in this modeling result, it is really hard to maintain a clear smoke layer. Smoke will be blown all over the place because this atrium is so narrow and so tall. It's like a chimney. And this is some animations of the result. And you can see the temperature and the CO. It's way below the results are way below the tenable criteria. The only problem is the smoke, the visibility, because the smoke is so dense and the smoke may block the view along the exit path. But again, you can see the temperature and the CO, the carbon monoxide, they're far below the threat level. So this is some result. See, at almost 10 minutes, the visibility can drop down to 30 feet, which is 9.1 meters in the corridor, and almost 10 minutes drops down to the same level of the visibility. Again, we increase the exhaust capacity up to 100 cubic meters, but you can see still the smoke layer, there's no clear smoke layer. Smoke is just a little bit diluted, but no clear smoke layer. And also, you can see the visibility is improved a little bit, and during the whole simulation, the tenability condition can be kept beyond the criteria. This one, we increased the exhaust capacity to up to 110 cubic meter per second. Still, no clear smoke layer. But the smoke density is reduced, so that means smoke is diluted, but not clearly keep the smoke layer up high. This is the fourth scenario. We open up the atrium top, and this simulates the courtyard, and also you can call this a natural ventilation. And the result kind of similar to even though I just said the airflow at the top of the atrium, with the natural ventilation is like 40 cubic meter per second, but the result is close to the that of the mechanical system with the 100 cubic meter per second. Again, the natural ventilation in the natural ventilation simulation, we didn't include the wind effect. We didn't consider the stack effect. So this is a kind of an ideal situation with the natural ventilation. The last one, we increase the mechanical supply at the bottom of the atrium and still rely on the natural ventilation. You can see the it's not improved so much. It's still kind of like the similar result with the natural ventilation without any mechanical supply at the bottom of the atrium. So now the conclusion. Well, we feel like the the fire and life safety strategy is relatively complicated in the tall and the narrow atrium. You have to use some kind of a decent engineering analysis to deal with the issue. These days, some people told me that in China, fire department is not so supportive to the engineering, some fire modeling analysis, performance-based analysis. But I feel like for some issue difficult or complicated like this, you have to use some decent tool to do the calculation. You cannot make the decision by guessing. So especially when the solutions with the solid glass wall is not so preferred by the architect, and the solutions with the fire shutters is so unreliable. So we think in this this kind of a tall and a narrow atrium, smoke control is a reliable solution. Also, in our analysis, fire modeling analysis, we found that it's hard to maintain a clear smoke layer inside the tall and the narrow atrium. Simply increase the mechanical exhaust capacity may bring more turbulence, which may bring more negative impact to the smoke control system. And also, we think the design target is to maintain a tenable environment by diluting the smoke rather than keep the smoke layer at the ideal certain height, ideally at a certain height in the atrium. We use the courtyard or natural ventilation as the reference for smoke control because in the tall and the tall and narrow atrium, there's no such kind of a design guide. So we try to use the similar courtyard as a reference. So the natural ventilation tells us that the flow rate, smoke exhaust flow rate from 40 cubic meters per second to 100 cubic meters per second can provide acceptable, tenable environment in such kind of atrium. Also, the natural ventilation has a lot of impact from the weather, from the vent size, from wind, and so on. So the mechanical system may be a more reliable solution. So, okay, that's it.